Value overflow. Oh my gosh. Am I even on the correct monitor right now? No. Because we were gaming. There we go. That's a better monitor. uint8_t. What kind of primitive, ridiculous programming language are you using that has a uint8_t in it? That's the craziest thing I ever heard. I gotta make my buttered toast and then we'll go. It's C. I never heard of that language. Is C like what grade you get on your programming assignments at computer school if you use that language? Is that how it works? buttering my toast, and then we'll start. What's the cache line size on like Skylake? Is it like 32 bytes or is it 64 bytes? My brain is telling me 32, but I don't actually know. I'm worried that the baby thinks cache lines are too small. You just got assigned mandatory sexual harassment training. Yeah, I know. That's why I kind of want to move my company out of California. Like, I'll probably get another office in the Bay Area for like the next year, but longer term, I think we have to get the fuck out of here. Out of the US? No, just moving to one of the states in the US that still maintains the attitudes that help the United States be the successful thing, become the successful thing that it is. I need to move all the employees too. Wow. Really? So it doesn't matter where the company is. It matters if somebody is working from California. Oregon? Fuck no, not Oregon. Maybe Texas, maybe Florida. I wonder if it works the other way. Like if the company is in California and the employees are outside of California, do they still have to do the thing? It's based on your mailing address. What if I get a mailbox in Reno? And then I drive there to get my mail. Okay. Today, we're going to deliver value to the people. And the final bit of value we're going to put together is a little more documentation about the relative pointer situation. And we have a whole feature test here that we could like copy and then like attack in some way, right? So we're going to have like and I'm just going to sort of like bust out what we're doing here. Okay. So we got some fun. I'm not rich enough to pull tricks like that. Yeah, I still don't know what is the relative level of richness before you can do serious tricks. Like, I know one or two people who have way, way more money than me, and they don't seem like they're doing these fabled tricks that supposedly the rich people do. So, like, I mean, maybe I just don't know, but they just seem like regular people to me. So, I don't know where that actually kicks in, if ever. If only I had bought Bitcoin in the year 2008, then I would know. You have to be verified on Twitter. Damn it. Okay. I mean, this down here doesn't look very good as an example. In fact, it looks like a lot of the tests there kind of got deleted over time. Okay, let's just start. Let's say the following things. On modern 64-bit CPUs, pointers are very large. They are 64 bits, in fact. 8 bytes. Okay, let's look up that cache line size. 64 bytes. I just closed chat. The fuck? Okay, chat's back. On 32-bit CPUs, when pointers were merely 4 bytes large, they placed half as much pressure on memory bandwidth, cache utilization, and related performance. And related performance critical whatchamacallits. Related performance critical resources. But with only 4 bytes, if you want to be able to, but 4 bytes only stores numbers up to about 4 billion. So, if you want your pointers to be able to point at any individual byte, then pointers would only be able to address 4 billion memory locations, or 4 gigabyte of RAM if you wanted your process to be able to use more than 4 gigabytes of RAM. If you wanted your program, you were just out of luck, or you would have to do something really weird. That's why we use 8 bytes today. But 8 bytes, but in the year 2021, honestly, 8 bytes is a little too big for a pointer. But this is what we have to work with. Work with by default on CPUs. The nice thing about 8-byte pointers is that they are able to refer to way more memory than we are going to worry about using anytime soon. Why care about 32-bit these days for game development? We don't. Almost nobody cares about 32-bit. Unless you need to target a platform that still does like maybe Nintendo Switch is still 32-bit, but like honestly nobody gives a shit about 32-bit. Unless they have legacy code that doesn't work. Or machine learning GPUs? No, because machine learning, almost none of the data is pointers. And on GPUs, almost none of the data is pointers. So it doesn't, I mean, if you mean 32-bit floats or whatever, I mean, sure, you use 8-bit floats in machine learning. I mean, that's just a completely different thing. Yeah, you don't use pointers in either of those things, though. Okay. So we can use them by default and not worry about questions like, is the data we are trying to point at going to be within range of the pointer? We can just work on making our program on getting our program up and running as quickly as possible, and then making it correct, and the data will just be a little bloated for a while. After your program is correct, you may wish to reduce the footprints of various data structures in order to get it running faster, or just to feel better about its internal aesthetics, or just so you can feel better about its internal aesthetics. Okay. One way to do this is just to replace pointers with indices. For example, if you have a bunch of strings, you can reduce their size, and you know all of them. And you know that you can make a table of most of these strings, then you can reduce the size of the pointers of those strings by turning them into small integers. Just put all the strings into a table, into that table. What's her job? Tables. Tables. Just put all the strings into that table and store the index instead of the pointer. if you know you will have fewer than 65536 strings, you can get away with storing 2 bytes instead of 8. Tables. Use bit fields and get even smaller. False. False. You don't need to use bit fields for that. Okay. Let me just, if you have a bunch of strings, then in many cases you can reduce the size Okay. Then what? What do we say? What do we say now? Ever found it worthwhile to use non-power of 2 chunks? I mean, yeah, when you're packing data into like save data, for example, or some file that you want to be small, yeah, absolutely. Absolutely. Okay. You can get away with storing 2 bytes instead of 8. What do we say here? This might make your code messy, since any time you want to use these pointers, you need to have bespoke code that knows how to translate the value into an address. Use these indices. Then you might be calling those all over the place. And if a third-party module wants to compress its pointers in this way, you are not going to know you are then, in order to use that module, you need to learn to use these functions to use and then so it seems useful to establish a convention to try to make this easier and more what do you call it? Standardized. So as an experiment in this language, we have a built-in facility for smaller pointers. So that they can be used generally with no external, with no contextual information needed. They are not like the string tables mentioned above. Instead, they are numbers, integers that let that indicate the target of a pointer relative to the memory location where the pointer is stored. For example, if we have a 2-byte relative pointer, this is treated as a signed integer if that integer is minus 32768, then the pointer points and the pointer is stored in location X, then the pointer points at memory location X minus 32768 if the integer is this is the maximum range of a 16-bit relative pointer. We are doing two things here in order Table of variable size structures and table of fixed size structures are different things. What? 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 In order to achieve generality, one, we are exploiting locality. If data are related and prepared in such a way that locality is maximized, then you can probably establish, then you probably just don't need to point at arbitrary places in memory, so you can establish a bound a reasonable bound on the distance a pointer will reach, and use that as the size of your relative pointer. Two, to make things easiest, we only support signed relative pointers. This way you don't have to, well, our relative pointers are signed integers. This way you don't have to worry whether you want to point forward or backward. Unsigned pointers would give you slightly more range, and we might think about adding them in the future, but currently all language native relative pointers are signed. Okay. So I think I'm just going to start, because we've had a bunch of words without any code. So I'm going to start doing some code. To illustrate how they work. And then we'll get into the more of the explanation as we go. I kind of want some warm liquid. Yeah, let me warm up some water and we will go. Doesn't null take up a value in the 16-bit range? Yes, we are about to go into that, in fact. Any absolute, any non-relative pointer, for example, P is, this will print that P is null. We can spy on the integer value of P. Let's set up a value called spy that lets us do that. Spy cast pointer x32 star P. Take the address of P, then cast that to. Okay. So, wow, I don't even have a console open. I'm just saying that the introduction suggests otherwise. Why does the introduction suggest otherwise? What did I write? I'm not aware of writing anything that is misleading, but if I did, let me know. I just don't understand what the misleading part would have been. Six, 5, 5, 3, 6. you know you will have fewer than 65536 strings, I mean, the string thing is a very specific case. Maybe you know that they're not null or whatever, right? I don't want to complicate this. But down here where we're actually talking about relative integers, that's a different thing. This is just an easy to think about example of how to use less memory to point at things, right? Also, why is null not a string? Anyway. Minus 32768. Okay. Oh, right. This is actually false, what we wrote here. It really is. It's minus 32767. Yes, that's a good point. Okay, I fibbed. Okay. That is correct that that was wrong, if that's what you're saying. We're about to explain what the wrinkle is. Okay, so okay. I never want to fucking see that. I will decide when to download a new fucking console, you assholes. Imagine if like every single program always did that. Like every one of the like 300 fucking shitty background processes that are running on Windows all popped up boxes saying, do you want to download an upgrade? Imagine if like I hit the tools menu and it says, oh, the tools menu has changed. Do you want to download an updated tools menu? Like that'll happen eventually. They're working on it, I'm sure. Okay. So boom, SPI is 0. This will show that SPI is 0 and P is null. Okay. Let's just let's make some floats for P to point at. Floats is 5. Float for floats. All right. Let's do this. This will be easier for people to read. 4 0 to 4. Float sub it. equals cast float it plus 1. Okay, that's easier to read. P equals star floats 0. Of one of these floats, just like we would with any, let's just do this. 2, just like we would with any non-relative pointer. Print the address of P, or print the address to which P points. Print the float that P points to. It had better be 2. No, 3. Actually 2, right, because we changed it. Okay, assert P is equal to 2. Great. Okay. Let's look at the integer value of P in this case. We are pointing into an array of floats. Boom. Wait, what? Spy contains a big number that looks like garbage, but we got the right value. What's going on? Let's print it in hex. To solve the mystery. Oh, you know, fudge. Okay, we'll just say this. The problem is, because this is on the stack, in this case, for example, it's a fucking negative number, so drawing it in hex, it's going to have a bunch of F's in it and shit, or like, I don't even, maybe not even, right? Whereas if we stored them like in a struct that's packed together, maybe that's a better example anyway. It's a little more convoluted to start because you're making like a struct with this stuff inside. But that's maybe more like a use case that you're actually going to want anyway, is data that are packed together. Because here it's going to be like it's going to be some bullshit. Oh, actually, what if it happened to be positive? Yeah, I mean, this is kind of what we would like to see, right? Because that's pretty clear. This is like, eh. So let's start with some packed data. The thing is, okay, we'll just do this intro, and then I'll explain why you need a pointer to be able to point it itself. Because the thing is, like, this points at floats, but it's not a float, right? So one of these, like, Rust or fucking Haskell weenies will say, like, it can't point in itself. So why are you worried about that? Why don't you just make it 0? But then we'll put a different example down there later. It can't point in itself. It's the wrong type. Okay. We actually, okay. Yes. Let's do this. Okay. Let's make an array of floats packaged in a data structure along with a pointer to those floats. This is a toy example, but represents something you would want to do in a serious program. Pack a bunch of data together that is easy to load, transmit over the network, or whatever. Package. But then my pointer is also called P. Let's do this. Package is a struct, P, right? And then floats. All right. And we're going to go using package. All right. Let's initialize the floats inside package. Okay, we can assign P to the address of one of these floats, just like we would with any non-relative pointer. Okay. So now we're pointing forward in memory for sure. There we go. Negative. Wait, what? Spy. Is this. See, this is a much better. This is much better when we can say exactly what it is. Spy is minus blah, 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 which looks like garbage. But when we dereferenced P, we got the right value. We got 2.0. So it is pointing at the right location. What's going on? in hex to solve the mystery. Okay. There we go. C. It's the C programming language, everybody. Whoops. Let's get rid of the base. Okay, 12. Now we see that the value is 12, which is how many bytes forward from the, which is how many bytes, which is star floats. This is not actually true. Fuck, because we still do the C thing of dividing by size of float, which is the number of bytes from star P to star floats of 2. Okay. We could actually, okay, let's make these 16 bits because, like, I don't know. Yeah, let's make it. Just let's get rid of all the F's. It's just too much respect. Okay, now this is going to come out differently as well. 32780. Wait, what? Why are we printing that as a positive integer? Oh, thank you. Thank you. There we go. Minus 32756. Okay, yeah, these are just smaller, smoother brain numbers that are easier to talk about, and it's fine. Okay. We're going to do this because this is the actual encode decode algorithm. Why the funny business with the high bit? The reason is we want to be able to represent null pointers regardless of where they live, regardless of where the pointer lives in memory. So we need to reserve one of the values in the range to represent null. In the integer range to represent null, in order to maintain consistency with the rest of the language to allow you to memset structs to 0 and so forth, we designate the integer value of 0 to mean that a relative pointer points at null. But then what happens if we want a relative pointer to be able to point at the memory location where it itself is stored? You might be tempted to say, let's just make that illegal. Nobody would ever want to do that. In the example above, we are pointing at floats, and the pointer itself is not a float, so pointing at itself would mean pointing at garbage. But there are quite a number of cases where self-pointing pointers happen naturally or are required to implement some algorithms. For example, suppose we want to make a linked list. Node is struct pointer s32 node. Value is string, or let's make it something small. Let's make it a float 32. All right. If the list is circular and contains only one node, then pointer will want to point at the base of its own node, which is the address of pointer itself. We do not want to, if we were to introduce weird, if this would cause us to mistakenly point at null instead, breaking the program, that would be very frustrating. Relative pointers that worked in this way would be much more error prone, and people would be less likely to use them. Okay. Instead, we can pick a value at one of the endpoints of the integer range to represent null. Then there are no holes in the range. Interestingly, 2's complement integers give us a natural candidate. The lowest negative number in the range, which is one further away from 0 than the highest number in the range, which is already a little weird. For example, 8-bit signed integers go from -128 to 127. If we use -128 to represent null, then the pointer can address a nicely symmetric range from -127 to 127. Okay. Which has always been a little weird. Okay. Symmetry feels good. I think preparation H feels good on the whole. But then relative pointers are non-monoidal. I don't know what that fucking means. It means they're not a surjection across the integers or whatever. Whichever one of those. Okay. You know, this is going pretty far into the weeds on something that people might not care about, but it's probably important for people to understand how they work. Right? Right. What happens when you do cast S16P? That's just a pointer to integer cast. We might want to talk about that here. This explanation is already going much longer than I imagined it would. Okay. The 2's complement value for minus 128 is OX. The 2's complement is OX80. Of the word. So if we have our number between minus 127 to 127, we can XOR with OX80, and then 0 is guaranteed to be unused because OX80 was not in the original range and OX80 XOR OX80 is equal to 0. Thus, we can use 0 to mean null, and all it costs us are an XOR and an add, which are pretty cheap on modern CPUs. Is an XOR with a fixed number with a constant. Because the add you would have anyway. The add is part of the relative pointer. Okay. So that's the explanation. Is there anything else that we need to say? We could talk about what happens when you cast it to S16, right? Oh, it's not a pointer to integer cast. We actually get I'm actually not sure that I like that. Well, we better cover this because I wasn't even sure what the answer was, I guess. Yeah. So those should match. Boom. We can cast from P to pointer to float, and this will give us the same value as if we had stored a full-size pointer to begin with. Assert absolute is equal to star float sub 2. Okay. Now, okay. what happens if we cast to S16 the size, the integer type in which the pointer is stored. Right now, we just get the integer value stored inside the pointer, the same as we got by looking in SPY. But I'm not sure this is the right answer for the long term, so this may change. Suggestions welcome. Maybe it should return the relative offset, or maybe it should just be the same as casting the absolute pointer to S16, which will most likely overflow, but and thus be not very useful, but makes very consistent language semantics that don't care whether P is absolute or relative. Okay. Maybe T is the null thing. Then readers will not wonder if minus 32767. No, this is the way to do it, I think. Because it's natural that it's null and that it's 0. And then we go, aha, but that means these other things, right? It's fine. Okay. I kind of want to go to bed, but we're going to keep going. I want to deliver the value to the people tonight. The line must be drawn here. The value must be drawn here. Okay. Pointers, what do I say? Pointers are not the only type that can be handled with relative values. That are not the only type supported with built-in relative support. Some compound types that contain pointers, like strings and arrays, also can be relative. Relative strings. Package, struct. String data is, I don't know, 100 U8. Value or bust. Hell yeah. Hell yeah. Okay. So, relative strings. Each of these strings is relative with type S8. Okay. What does string tilde S8 mean? It is equivalent to the following struct. Data is pointer tilde S8 U8. Count is S8. We won't go into anything too speculative here. It is equivalent to the following struct. So it's 2 bytes large and can't point very far, but it's far enough for this example. Let's initialize the package. So we're going to go 0, 1, 1, 2, 2. String data 0. String data 5. 11. Its index, it goofed. Oh. There we go. There we go. Okay, let's print relative pointers, relative strings, relative arrays. We're getting fancy with our punctuations. We are punctual. Okay, let's put that. Now we can see things. Relative strings, relative arrays. Okay. It's strings 0, not string 0. Strings. What are relative pointers relative to? Well, if you had been here, you can rewind the VOD and go see what they are relative to. We covered that in the values. Is anonymous cheerer a Twitch thing? How come I can't ban this thing? It's unbannable. What a garbage. What a garbage. All right. As we mentioned earlier, one use case for relative pointers is when packing data. Shrinking the size is one benefit, but another benefit is that because relative pointers are just integers, they don't have to be fixed up when you load or transmit the data. After you load or transmit the data, you can just use them verbatim, and this makes them convenient and fast. So let's make another package and copy the data. Another is a package. Mem copy another package size of type of package. Actually, let's just fucking okay. For packaged or for another dot strings, oh, it index it. Oh, it. This mem copy may as well have been a load from disk of pre-baked data or whatever. We don't have to adjust the pointers to compensate for the load location. We can just use them. Neato. Okay. You might feel like you want different sizes for the data and count members of a relative string, but we do not support this currently. Right now, they both must be the same type, which probably covers the majority of use cases. The options are string tilde 8, string tilde S8, string tilde S16, string. It is serializable, just like our string tilde S8 example above. How does that sound? Who does not want money? I mean, I think the disruption of my attention away from the important things that the people in chat are saying, I think that degrades the value of the stream by more than 1 cent. And I would ban the fuck out of that account if I were able to. What happens if I type it? /ban an anonymous cheerer. You cannot ban anonymous users. Well, that sucks. Ban Twitch. I am tempted to ban Twitch. Okay. We're now going to do relative arrays. I just closed my fucking thing again accidentally. I banned myself from my own dashboard. All right. Okay. Arrays in this language look a lot like strings storage-wise, and so they support all the same relative forms as well. The array views. You know, fixed array probably shouldn't. I wonder what happened. Array views. Um, resizing arrays do not support, do not have relative versions currently because it doesn't seem worth the hassle. So that wasn't an error, but it is now. Dynamic arrays do not, it's not called fucking dynamic anymore, though. Resizable arrays do not support relative pointers. Okay, that's fine. Resizable arrays do not support relative pointers. This might change in the future. Okay. I think this actually will work, but it shouldn't. Fixed arrays have no meaning with the relative modifier, so right now it does not even parse. Fixed arrays do not use any storage for pointers, so a relative modifier has no meaning. Right now it doesn't even parse. You know what? There we go. I want it to be the same width as this line. Oops. There we go. That compiles. And if I do that, boom, we parse the declarations. But saw this instead. That's not a very good fucking error message. Okay. We're going to do that. We're just going to put those at the top. Ah, relative pointer docs. We're doing that right now. Okay. We're canceling YouTube because of the dislike thing. Where do you even go? I guess you have to go to like Rumble now. Isn't that the new YouTube? Rumble. Let's get ready to rumble. Okay. Let's go back here. You know the drill by now. We make a package. We say, let's go back to our floats example. Okay, float. We're going to say window. Okay. Whoops, that is, yes. Whoops, I goofed. Window.data. Whoops. So many goofs. There we go. Okay. How's that? Minimum of verbiage at this point because I'm tired and also we already explained all this stuff. Aha! Okay. Oh boy. That didn't work. Why the hell didn't that work? Oh, you know what? I don't think we could assign it with equals because that'll do. Wait, no, because the data pointer is correct. I think there's a fucking bug. I think there's a fucking bug. I think there is a fucking bug. You guess if the relative pointer has a different size than the type it's pointing to, the compiler has to check pointer arithmetic for crossing 0. What? No. What do you mean by crossing 0? The size offset between the pointer type and the data. I don't know what you mean. No. The value is not like multiplied like C pointer math or whatever, if that's what you mean. But I'm not sure what the supposition is there. Okay. Unsigned pointers or to be constant so that we don't need to store data about them in the pointers. But now that we have nice routines like add data segment, modules compiler dot add, is it called add data segment? Add global data is actually add global data, which can be mapped to constant global symbols we can do stuff like pack data at compile time that is at a known runtime offset from said symbol. So this would have use. But we don't want to overcomplicate relative pointers until we gain some real world experience using them in this language. Okay. Currently, relative pointers are not checked for overflow on assignment. if you try to point at memory that is too far, this will silently fail, and you will be sad later on when you try to read the value. It is likely that at some point we will add bounds checking to relative pointer assignment as a build options into the build options the same way you can control array bounds checking. To achieve standardization, to help modules coordinate with each other, maybe it's not necessary to have all relative pointer types built into the compiler. Maybe we can instead just provide a module with some relative pointer types, and you just have to call functions to use them, but there are a wider variety. We'll see. Okay, so this whole thing that we copied, I do not care about that at all. And I think we're done. Is there anything we are missing from this example, everybody? Do you provide a packaging module with functionality similar to what I once demoed? Packaging? When did I demo packaging? I'm not sure which demo you mean. We definitely have demoed like setting the icon on the executable and stuff like that, but I don't know about packaging. I don't even know what that means. Okay. Suggestions? Any suggestions? Or do I simply deliver the value to the people? Taking a struct and transforming absolute pointers. Oh, I see. I thought you were talking about software packaging. We don't really have a module that does anything official there yet, and I think it's just that we just haven't done it. I mean, whatever code I wrote that time, I kind of vaguely remember the stream you're talking about. I don't even know what I did with that code. The question is really, how do you control that? Like, do you just put notes on the struct to determine relative pointer sizes? Is there some like API where you tell it what to do? You know, it's a little bit unclear. That's sort of the biggest question to me. I mean, I think that would definitely be a useful function to provide to people, but we just haven't made an official thing yet. Okay, I'm going to deliver the value to the people. Let's do one more thing before we do that. So I'm going to check in. Wait, why do we have a change to typer? Oh, that. Yeah. Yeah. Okay. Great. This is very good. Let's see if we could fix. I don't want to work on that compiler bug right now because that probably needs brain power. But but saw this instead. You could probably make that. Oh yeah. But saw this instead with literally nothing. All right. Shut up. Stupid ass existing breakpoints. Okay. Token. 289.22 to 289.23. I think it's that space. Why are we getting last token? I don't understand that. This is weird. Why are we ending up at a space? Let me just do this for a second. Debug. Okay, that's the current token. So get last token. Doesn't. I don't understand why we were going to the last. Like what? What even is happening? So we expected a semicolon after it. Reported parse error. False. Like what? How did we parse a declaration? Why don't I just fix this? Okay. It's like all right. Okay, so we do it instantiation. It's wait, what? This looks wrong to me. This is very old. Because, like, you could type frickin' 0. Okay. We're just going to be lame. And we're just going to put the pointer modifier. All right. Fuck it. You know what? We have this array type. I'm going to do this the right way. We have this array type. Fuck it. Okay, wait. Array view. Array fixed. Okay. C++, you got to do everything twice. Parse array dimension, array dimension. Okay. Bruh. Sure, I messed up a billion things. Why is this all erroring? Ugh. All right, we're going to have to deal with that later. Well, did I destroy everything in the universe? Okay, so now we are allowing this thing fixed arrays do not support relative pointers. Yay. Okay, so it's not a parse error anymore. Okay, great. Let's restore this to whatever the hell it was doing, even though that is sus. Come on. All right. You recall the packaging function took the wanted integer type as an argument. Well, I mean, that helps if you have one type for everything. which I can imagine lots of cases when that's not really true. Dynamic, okay. I changed the phrasing. Change the phrasing. Kappa. Kappa. Okay. Now what? I think I checked that in. Oh, let's test it on Soapman. Okay. Hopefully there's no check-ins. I don't even know. All right. Let's update the version number to 9.3, built on November 10. Holy crap. This is a resizable. It's not called dynamic anymore. Update the version number for the next beta. Okay. And then I update over here. I do a make. Maybe for some kind of relative pointer packaging function, maybe it makes sense to just keep it as simple as possible and have there be only one type. I don't know. Like I said, I haven't thought about it very carefully. All right, so I'm running the LVM tests. And now I'm running the Linux tests. Update the Linux binary. Okay, great. Now, we can make the distribution maybe if the other thing is done. Let's see if we got nope. 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 It's not ready yet. That's fine. You know what? Let me, I am adding someone to the beta right now. So we're going to go into high security mode. I want to send this person an email. Added to the compiler beta. Okay. Okay. Added to the compiler beta. I have a stock email that I send to the people. I paste that, and then I run frickin' Discord, and that's going to take like a minute. Oh, we already ran it. Okay, so I go to the beta channel. I say invite people. I make a custom invite link that only has one use. I generate the new link. I copy. I paste it into the email. I send the email. I go to my official beta list. I add to beta. Boom. Okay. Now, let's see. One 16912. All right. So I could update. There we go. I can go. Boom. Success. Okay, I'm going to go back into high security mode for a minute. That was a very brief low security mode. Going to get the file. Going to put it in the upload location. While it is uploading, I will send the email to the people. We're BCCing to 119 people. New compiler beta. Bam. I will also send to the programmers on our team new documentation added. How to 300 relative pointers. Enhance the pixels. Oh, whoops. I sent out the email and it has no link in it because I went too fast. If you want to succeed in the compiler industry, don't go so fast. It will help your downloading to have the link. Sorry. There we go. There's the link. Okay. All right. Look at all the betas, dude. Okay, we're going back into low security mode. I used my private email. I mean, every single beta email is from my personal email address. Which is probably why people reply to that with bug reports and it drives me nuts. But I don't have another email address. All right. Unless you mean a different... Did I send that somehow from a totally different email? No, that's the one I usually send. Okay, I got to get up early in the morning. So let's start the new changelog and then I'll go to bed. Job well done. It didn't have the link. Yes, well, that was definitely my fault. Definitely. Well, we found a compiler bug today. Not that surprising because relative pointers are still like not super heavily used. So once in a while, there's just something going on with them, you know? But then when I fix that, we will have a test case. All right. Thank you, everybody, for coming by. I'm going to go to bed. We had good times today, I hope. We delivered value to the people. Oh man, I let him put a frickin' Euro character in here. Get the Euro characters out of there. Good night, everybody. See you later on. See you later on.